Hello and welcome to today's lesson on braking distance. Our plan for this lesson is as follows. First, we'll define braking distance and spend time understanding its details. Next, we'll outline the factors affecting braking distance, ranging from weather to vehicle condition. Finally, we'll highlight the importance of understanding these factors for driving safety and discuss strategies to maintain safe stopping distances. So far, we have discussed stopping distance, various safety features in vehicles, and the factors influencing reaction time. Building on this foundation, we can now delve into the specific factors that affect braking distance. Let's get started. Let's start by understanding what we mean by braking distance. Braking distance is the distance a vehicle travels from the moment the brakes are applied until it comes to a complete stop. This distance is crucial for safe driving, as it determines how much space a driver needs to avoid collisions when an unexpected stop is necessary. Let's now look at factors that affect braking distance. Firstly, the speed at which a vehicle is traveling is directly proportional to its braking distance. The faster a vehicle is moving, the longer it will take to stop. Recall that momentum equals mass times velocity. Given this, a car will have more momentum if it is traveling at a faster speed. Also recall that force equals change in momentum divided by time. Given that a faster car has more momentum, if we apply the same braking force, then it will take longer for a faster car to stop than a slower car. Another way of thinking about why braking distance increases at higher speeds is in terms of kinetic energy. A higher speed means the vehicle has more kinetic energy. Kinetic energy is given by the formula 0.5 multiplied by mass multiplied by velocity squared. As the speed increases, the kinetic energy increases quadratically. Therefore, at higher speeds, the brakes must dissipate a significantly larger amount of energy to bring the vehicle to a stop, resulting in a longer braking distance. Secondly, the condition of the road surface also plays a vital role in braking distance. For instance, wet or icy roads reduce the friction between the tires and the road surface, making it harder for the vehicle to stop quickly. Friction is the force that resists the motion of the vehicle's tires against the road surface. On dry and recently tarmacked roads, friction is at its highest, which allows for shorter braking distances. However, on wet, icy, or uneven roads, the friction decreases, leading to longer braking distances. Additionally, gravel or sandy surfaces can cause tires to skid, further increasing the distance needed to stop. Another consideration is whether the car is driving downhill. If you are going downhill, the braking distance increases, because the additional force of gravity is opposing the force of braking. Finally, adverse weather conditions, such as rain, fog, or snow, can significantly affect braking distance too. Rain can create a layer of water on the road surface, reducing friction and increasing the risk of hydroplaning, which occurs when a thin film of water forms a barrier between the road and the tire, preventing the tread from gripping it effectively. Snow and ice make the road surface slippery, greatly increasing the braking distance. In such conditions, drivers must reduce their speed and increase their following distance to ensure they can stop safely. Finally, the condition of the vehicle itself is another critical factor. Worn-out brakes, for example, cannot generate the necessary friction to stop the vehicle quickly. Similarly, low tire pressure or worn tires can reduce the contact area with the road, leading to inadequate friction. Mechanical issues such as faulty brake systems or suspension problems can also compromise braking efficiency. Regular maintenance checks are essential to ensure that the braking system, tires, and other critical components are in good working condition to minimize braking distance. Understanding the factors that affect braking distance is essential for driving safety. Longer stopping distances mean that drivers need more space to come to a complete stop in emergencies. This is especially important at higher speeds or in adverse weather conditions, where the risk of collisions increases. Drivers must adjust their driving behavior based on the prevailing road and weather conditions to maintain safe stopping distances. For example, reducing speed in wet or icy conditions and leaving more space between vehicles can help prevent accidents. Additionally, regular vehicle maintenance, such as checking brake pads, tire pressure, and overall mechanical health, is crucial for ensuring that the vehicle can stop effectively when needed. In summary, the braking distance of a vehicle is influenced by several factors, including speed, road conditions, weather conditions, and vehicle condition. Understanding these factors and their implications for safety can help drivers make informed decisions and take necessary precautions to maintain safe stopping distances on the road. Remember, effective braking is not just about pressing the brake pedal. It involves understanding and adapting to the conditions around you to ensure safety for yourself and others on the road. Watch the rest of the GCSE physics course at Sophos Education.